Hello, hello. Am I back? I think I'm back. Well, anyways. Someone let me know if I'm back in the chat. But... oh, I am back. Alright. Well, Vincent, if you are having issues, you can always ask for help. But, okay, my pen works now. So anyways, let's see what this is all about. So we have probability density function. We know that if we integrate it from 0 to 4, it should be equal to 1. So I can probably calculate what p is once I get there. So I gotta integrate this in parts. So first from 0 to 1. And then that's going to be 3px dx. And then 1 to 4 of... well, I'm going to multiply this p in. Well, actually, does it even matter? I guess not. And we know that it should be 1. And these are both pretty easy to integrate. So this is going to become, what, 6, nope. 3 over 2 p x squared. And then this one over here, negative p over 2 1 minus x squared from 1 to 4. And then this is all equal to 1 after we plug stuff in, right? So 3 over 2p minus p over 2 so negative 3 squared. And then if I plug in 1, this is 0, so I don't need to do that part. So what is this, 9? Over 2p, so 6p, and then we know that this is equal to 1, so p is 1 over 6? Sure. Is Vincent still here? Okay. And then, now that we know p, we can find probability of x being less than 2. Because now we can just take these integrals. Okay, so this is a calculator one, right? So, first off, if p is 1 over 6, then 3 times p is 1/2. So I'm going to integrate this one, and then from 1 to 2 for this. And again, this is all calculator stuff, so I'm gonna go to Desmos. So the integral from 0 to 1 of x over 2 dx, and then I guess I'll call this A, and I'll call this answer B, and then A plus B. So this 0.167. Sure, let's go with that. Okay, so next up, given that this is equal to this, and then A is here, find the value of A. Okay. I guess we do something like this. I'll probably find an expression including A if I do this general integral, and then same thing over here. But before I do, my first question of the night. How do I simplify this? BD is 4 squared plus 8 squared minus 2 times 4 times 8 cosine theta to this 4 square root 5 minus 4 cos theta. So one thing you need to remember, that cosine law, the length of BD is not this. This is the length of BD squared. So the length of BD is the square root of all of this stuff. So this square root is where this square root will come in. And then basically notice that all they did is they simplified the radical. They took out a 4. So then we just need to simplify this and then factor out, well, a 4. So let's see. This is 16 and then this is 64. So altogether, that's what, 80? And then likewise, yeah, you can probably do it from here. Whatever this is, 2 times 4 is 8, 8 times 8 is 64. Yeah. So then you just need to do like 2 steps to get to here. And then you're done. Okay, let's see. A is less than 1. Yeah, you should follow the formula carefully. So A is less than 1, so then I can split this integral from 0 to A. And then A to, I think it was 2. So this is the probability of being between A and 2. So we can probably evaluate this, right? So what do we have? So here's the first part of the integral, and then over here Here's the second part. And then we can plug in our x values. Custom burrito emote. You can just use the burrito emoji. What is word going around about the burrito story? Okay, and then if I plug in 2, this is -1, and then I square it. So this is -1/12. And then I'm gonna add this. Look, if you can't interpret what a burrito would mean, then I don't know what to tell you. Okay, so here's the left expression for this probability. And then we can do the exact same thing over here. Now notice that 3 times a, if I multiply even the lower boundary by 3, then this is between 1 to 2. So I don't need to split this up into 2 different parts. I just use this middle part. So what does this look like then? 3 from 3a to 2. Yeah, and then of course I know this integral already, it's right here. Of course, there's a 3 now from over here. And these boundaries are, this is 3a. The burrito incident of 2021. It's not an incident. So let's see. If I plug in 2, this becomes 1, and then 3 over 12 is 1 over 4. And then I have 3 times 1 minus 3a squared over 12. What happened to the music from before? What do you mean? And then 3 over 12 reduces. It was better before. It's the same playlist. Look, I'm very limited in my options because I can't play things that are gonna be flagged for copyright and then my video gets deleted. So I don't know what to tell you. Here. Some relaxing music made for sleeping. Join music making club? I don't have time for that. But anyways, okay. So this is the left probability. And then I just found the right probability. And then I know that these two things are equal to each other. And then basically I can solve for A using a graphing calculator. So I'm just gonna graph each function as well, each side as a function and then find their intersection. And as long as I did my integrals right, this should be fine. So let me just type this in. You tried to plug this in and it was not happy. Okay, let me check it out. Okay, so here's my two solutions, probably one at 0, and then right here. So at 0.696. So I guess A is 0.696. And then I think I'm done the question, right? Nope. Wait, yep. So let me check this answer and then I will see what was not so good about your graphing calculator work. Okay, 2/6, that's good. Part B. I did not get 2/3. I did get 1/6 though. I don't know how I messed this up. Oh, I put in the calculator wrong, that's why. I put in 1 when the function is 4. So that probably means that my other answer is wrong. Oops. Well, let me see if I fix this real quick. Because that means that this is 4. And this one is 4. And then 4 minus 2 is 2. So this one is 3. And then 2 minus 2 is 4. This is just 1. Okay, I think I have it now. 0.4 something. And then there's another one over here at 2.33. Okay, I messed up the function, so everything went wrong. The process was right, but man, I need to be more careful with how I copy this stuff. Okay, so let's see. Plug this in. What the heck is this? What do you... How did you even get here? And what are you trying to do? You're trying to solve for x, right? So did you put this as like a graph? And then you try to find out where it's an x-intercept? So 2x squared then what do you mean your GDC is not happy with it if you didn't even put it into a GDC? Hey Tofu Char, how are you? Not bad, you know, Sunday night, chill stream. Okay, well, if this is the correct thing, and you want to find out where this is equal to 0, then apparently it's a possible answer is right here. I don't know if you can see that. Negative 1.098. And then I think there's going to be another one over here at 0.5634. I don't know if that's what the answer key wants, but those two are where it's 0. Yeah, so you could have just put this as a function and then solve for 0. Hello, Oliver. How are you today? Oh guys, I'm so sad. So the gym that I went to just announced that it's closing. And kind of because of COVID. They couldn't survive. So now I'm gymless and I need to find a new gym. It was a really good gym too. Okay, let's see. I got 2 graphs. Just delete COVID, I wish. Going to watch Tenet? Is that the weird time traveling climate change movie? Well, have fun. Thanks for leaving me on in the background. I'm okay. You know, day before work. Doing math. Okay, so let's see. They both go through this point. And then here are the differential equations. And let's see, show the tangent at this point is normal to that point. Okay. Well, we can just plug in x and y to get the tangent gradient for each function. And then we just need to see that if they're negative reciprocals of each other, which they probably are. Alrighty. I'm not mad. I'm just tired because it's Sunday. And then, you know, that means I have work tomorrow. Okay, so let's see. F prime at 1 and 0. Ugh. Serpent just did a whole question wrong because they couldn't read properly. Why are they called cosine and sine? Because there's actually some history to that. So let me tell you. So sine of an angle, right? Sine of an angle is literally, as I said, defined as taking the opposite side of some right triangle and dividing by the hypotenuse. Now, cosine is actually sine. The co part stands for complement. So cosine actually stands for complement sine. So what exactly is the complement? It's talking about the complement of this angle. So two angles are complements of each other when they add up to 90. So this angle plus whatever. So if you ever need two variables for angles, the other one you use is this one or this one. Now, because of geometry, this angle right here is always going to be the complement to this angle, because these two need to be 90. Yeah, we can use it in golden ratio. But because this one's 90, these two have to be 90 together because of the triangles, angles in a triangle thing. So what this is saying is the cosine of theta means you take the sine of the complement. So in other words, you're taking this opposite over this hypotenuse. But then this is, you know, according to naming using theta, this is the adjacent. But that's why it's called cosine. A little history for y'all. So cosine theta is actually this bottom side over this. So there's actually only two trig ratios, I guess. Sine and tan. Pretty epic? I guess so. No one ever tells you because no one knows. This stuff's like ancient history. It's not a lie. It's just, like I said, complement sine means that you're taking the sine of the complement angle, which is right here. Okay, so let's see. This is going to be 2. And then this one is going to be -1/2. So obviously 2 times -1/2 is -1. So this means that they are perpendicular. Easy peasy. Okay, and then we need to find g of x. So let's start with the derivative, which is this thing. And then we need to find the function, so we need to integrate this. The issue is, well, you have an x and a y, so this is troublesome. Luckily, I don't think you have that many options. This is not separable. So what else? What other options do you have in HL? Oh no? What's oh no? Now the work I erase for is for the next question. Oh no. Okay, I guess you only have integrating factor. So let's see, if you can collect your y's on one side and have the other side just be x's. Well, it's fine. Even if you erased your work, you already did it, so it's like not a big deal to recreate it. Yeah, you really can't read. Oh, not you. Oops. I thought that was Serpent saying that they can't read. Okay, let's see. I move this over here. And then now this is in this format. So -3 is my p of x, and then this is my q of x. So I think we just go through with the integrating factor. So according to this, we just take the integral of p of x, and that's e to the power of whatever, so here it is. And then I never remember how this works. I know you take this, and then you multiply it to both sides. And then we integrate both sides. But this is where things fall apart. I don't remember how this integral works. So I'm gonna need to Google integrating factors. Okay, let's see. So it says here if I integrate both sides, then I get this expression. So my function, which was g of x, is equal to the integral. Okay. So we'll just skip the work and then okay, so apparently this stuff all just turns into this. So all I need is to integrate this top part. And to do that, I will probably use by parts. So let's see. So here's gonna be my u. Maybe I want the negative to go with my dv instead. I think that makes more sense. So your v is 1/3 e to the negative 3x. Yeah, this looks about right, I think. I don't think anyone in chat can tell me otherwise. So let's see. So here's my u times v, and then I subtract the other integration by parts thing. Then this was I of x. Okay, and then we just need to do this part, and then maybe simplify this part. So let's see, x over 6, e to the minus 3x. And then this thing, okay, it's a plus e to the minus 3x. And then, what's 6 times 3? 18. So I think this is right. And then your e's will cancel. So this is g of x, I guess? History chat. In my chat room? Am I done? No. Sadie99, thanks. And then let's see, use Euler's method with steps of 0.2 to estimate f of 2 to 5 decimal places. What the hell's Euler's method? Oh, right here. So yn plus 1 is yn times h times f of x, y, and then xn plus 1 is xn plus h. What? I should know this, but... Okay. Sure. Wait, so I need to find f again? Do you get marks for drawing, redrawing diagrams? Depends. If they already gave you it, then no. But let's say they don't give you a diagram, then I think you get maybe a mark. Wait, so I gotta do this whole process again and find f? Oh, I guess I don't. Okay. Oh, I messed up this. My bad. Silly me. I forgot a plus c. And then I know g of 1 should be equal to 0, because they told me that. So this is equal to 0, which means that c is negative 2 over 9e to the power of negative 3? Yeah. Okay, and then now I know this, and then I can put it back in here, and then I'm done. And then g is this whole thing. Let's see. Okay, Vincent seems to have taken care of your question. Did you draw the picture? Because that shouldn't be that difficult to visualize. Okay, you know, as I was doing this, in my head I was also saying don't forget the C, and then I ended up forgetting the C. But this seems about right. You're dumb? Okay, we're gonna use steps of point 2 to estimate this, and then Euler's method says yn plus 1 is equal to yn plus h f of xn yn and then xn plus 1 is xn plus h. Okay, I know that on f I have the point 1 and 0, so this can be my starting x and my starting y. Okay, so let's see. So y1 is y0 plus 0.2 times something. Man, I'm just gonna cheat right here. 2xn plus y squared? What? Oh my god. So this, okay, this thing is actually the derivative. Okay, I understand. My bad. Anyways, I'm getting frustrated with this because I hate Euler's method. Well, I don't hate it, but I didn't remember it. So let me check. Let's see. I know I had some questions. For the arcs and sectors booklet, for questions 12 and 13, the answer key has a second method, but I don't get what they did with it, or how they did it. And then Charlie Bell, why do you send me a burrito emoji? Because you need to be able to understand what that means. It encapsulates the answer to your question. And if you can't interpret it, then I don't know what to tell you. So Charlie Bell emailed me requesting to set up a time to do a retest. And then I replied with a single burrito emoji. And yes, some other student of mine also requested to have a retest. And I sent them a single taco emoji. What do you want from me? Nothing. That's the answer to your question. You just need to know how to interpret it. I want a taco? No. There are no good tacos in Vancouver. Okay, so this is question 12. And then the answer key has a second method. What are you even supposed to do? So here's this thingy. And then this sector is 3 over pi. And then this arc is 2 over 3 pi. And then we need to find the radius and then theta. Oh, don't you just plug in... Don't you just have a system and then you can solve it? So let's see what they did. Okay, setting up and equating ratios. Okay. So I would not expect anyone to do it this way. But because radians are so useful, because we can think of, you know, areas as ratios of angles and things like that, we can do the same thing, right? Finding ratios of areas and ratios of arcs. So the full area of the circle is pi r squared, and we know that we have 4 over 3 pi of that ratio. Likewise, the ratio of the circumference to the piece of arc should be the exact same ratio because they're the same angle. So then that's what they were doing. So I think from this you can solve for r. And then you can go back and then solve for theta afterwards. But like I said, that's not something I would have expected anyone to do. But, you know, it makes sense, right? The ratio of this arc compared to the whole thing should be also the same ratio as this sector area to the whole circle. Can you do 25C in the triangles one? Triangles one... This one? Okay, so we have this set up. And then you need to show, using cosine rule, that AC is going to be this. So that should be pretty straightforward. And then use the sine rule in triangle ABC. And then find another expression for AC. Okay. And then, hence, find x, this angle, to 2 decimal places, and then you can find out what AC will be, and then you can find out angle y, and then you can find the area of ACD. So what's the big deal with this one? Where are you being stuck? Okay. This is a graphing calculator question, right? Okay, so you know in part A, right, you can express AC using cosine law as this. And then part B says we use sine rule to create another expression for AC. So this is sine rule, right? Sine law. So AC is 4 over sine 30 times sine x. And then well, we can simplify this. Sine 30 is 1 over 2, I think. So then this just becomes 8 sine x. So hopefully you're okay with this. Now, because we have 2 expressions for AC, that means that these 2 things are equal. This is really dumb. Because you can just use sine law to find this angle and then find out x. But what they wanted you to do is solve this equation using a GDC. So we'll just go their way for now. So here's 8 sine x. And then instead of finding their intersection, I'm gonna find out when this function is gonna be 0. I'm frozen? You're frozen. Refresh the stream, maybe. I'm frozen? Hey, Snake Star. Am I still frozen? Someone let me know. Snake Star says no. Maybe you guys just need to refresh your stream. Bruno Luzzi says no. Okay, good to know. How are you doing, Snake Star? Any more tests? Did you finish your EE actually? You were working on that last time I checked, right? History EE? Uploaded TOK essay and EE on Friday. Congrats. So what's next on the grind? But anyways, Serpent. So from part B, you have this expression for AC, and then you equate that to part A, and then you just move it over to one side and solve when this is equal to 0. And then I should make sure that this is in degrees. So, English grind. So then here you go. Is this the answer? 8.6 degrees? Or maybe it's 101 degrees? Don't think so? Oh wait, that's X. Wait, that's CI. This is question 20 something. 25. Wait, 111.32. Isn't that what I had? Yeah, right here. 111.32. And then they're both answers? They're both possible answers, but the angle X is obtuse from the diagram, so we choose this angle here. 111.32. And then now you can find out AC, because now we know what the angle is, and you can use any of the two former formulas. The easiest one to use is the 8 times sine. So you can go from here, I think. Okay, so I'm working through this Euler's method and I have to do this 5 times because I'm starting at 1 and I need to go to 2 and the steps are in point 2. Okay, so I plug in 1 and 0 into the derivative, which I already did earlier. That's just 2. So this is 2. And then x1 is, well, 1 plus 0.2, which is 1.2. You hate calculus? Are you in HL? Calculus isn't that bad. What do you hate about it? Optimization has been difficult. Analysis and approaches? What's so bad about optimization? You just take a derivative, make it equal to 0, solve for x or whatever, and then probably justify it using first derivative test. Do you have any questions? Practice questions? Not at the moment. Likely in the future. Yeah, probably. I mean, what's difficult about it? The concept or just actually putting it into practice? There's lots of optimization questions out there. It just takes some practice. Okay. So we repeat this until we reach an x value of 2. And I'm sure that there's a faster way on your graphing calculator. I'm going to use Microsoft Excel. Oh wait, I don't have it installed on this computer. Never mind. I can't do it. Ugh. I really don't want to do this table. So basically you run through it, right? So word problems, understanding the word problem. Okay, so we add 0.2 for the x's each time, and then to calculate y, we take the former y, and then we add 0.2 times the value of the derivative when you plug in the former x and y values. So this is the part that I just don't want to do 5 times. So I'm not going to do it. And then blah blah blah, you get an answer. And then everyone's happy. Hi, I'm not 5 a.m. How are you? Alright, then the hardest one. The difficulty bar is completely filled up. And I have a feeling this is not going to be fun. Okay, let's see. This is HL stuff, yeah. You know, I was looking at the stats. Although I don't get a lot of viewers, my VODs get a decent amount of views. Like, lately it's been slightly under 100, but then now patterns are starting to emerge. So whenever I do AP Calculus, I only get like 30 views. When I do SL stuff, I get like 100, and when I do HL stuff, it was around 100 before, but now it's starting to decrease. So I don't know. Is the audience trying to tell me that I should focus on SL stuff? Maybe. But then I feel bad for the HL people. Stalking students? Nah. Maybe it's all those people from Reddit when I advertised myself there a while ago. I wonder if I should repost, because I feel like more people could probably know about me. Because, you know, exams are back on for most schools, I guess. Snicker 1X, thanks. Okay, let's see. Ice cream company advertises free gifts to customers who collect 4 coupons. Coupons are placed random into 20% of all ice cream bag stick things. Oliver buys ice cream sticks and he opens them one at a time and sees if they have a coupon. So probability that Oliver obtains his 4th coupon on the nth ice cream stick opened. It is assumed that the probability that an ice cream stick contains a coupon stays at 20% throughout the question. Show that x4 and x5 are this. Okay, so the probability that he gets 4 coupons on the 4th popsicle stick means that he needs to get 4 coupons in a row, right? So this is the probability of getting 4 coupons in a row. And the probability of 1 coupon is 0.2, and they're independent events. So the next coupon, the probability of getting that one doesn't depend on an earlier event. So then this is just 0.2 to the power of 4, which is 0.16, right? Just like what they said? Oh, 0.16, 0.016. So easy enough to do. So the probability that he gets it on his 5th coupon, or his 5th popsicle stick, means that one of the popsicle sticks is not one of the first 4 is not a coupon. So this is the probability that one of the first 4 is not. And then this is multiplied by the probability that the 5th one is. So probability of a coupon. Okay. So out of the 4, we need to choose one of them to be the not popsicle one. This is like binomial probability stuff. So then that one that doesn't have a coupon has a probability of 0.8. And then we have probability of 0.2 to the power of 4. Oops, not 4, 3. And then we multiply that by the probability of the last coupon, which is just 0.2. So if I put this all in, I will probably get this thing right here. So let me open up my calculator. So let's see, math, or 4C1. 4C1 is just 4, so I don't even know why I'm doing this. So 4 times 0.8 times 0.2 to the power of 4. Yeah, so we're good. Okay. Then let's see, it's given that the probability of x equaling n is this formula. Okay. Then I need to find the value of a and b, and then a and b are these variables. But I do know that when x is 4, it's going to equal this, and when x is 5, it'll equal that. So then I can plug in my values for n, and then basically I have a system, and then I can solve for a and b. So let me just copy this. Actually, let me copy all of this. So p of x equals 4 is equal to 1 over 3750 times 3 times 16 plus 4a plus b times 0.8 to the power of 4 minus 4, which is 0, so I guess this is nothing. Well, I'll just write 0. And this is equal to 0.0016. Yeah. And then we can plug in 5. And here we go. We have this pretty easy system to solve. So I'm just gonna graph. So 1 over 3750, right? And then 3, 16 plus 4a plus, well, actually I'll change these to x and y. And then this is equal to 0.0016. And then 4 over 3750. And then all of this stuff. Okay, so let's see where they intersect. Right here, at -5 and 6. So A is -5 and B is 6. Okay. Then we need to deduce that this one divided by this one is going to equal this. Okay. So I know what this is, right? I'm gonna have to keep copying this over and over again. Okay, after plugging in my values of a and b, here's what p of xn is, and then I'm going to divide that by p of xn minus 1. Wait, this is factorable. This will make it easier if I factor this right now. And the reason why I'm factoring is it's easier to find x minus 1 if this is factored, because then I just replace this and this with x minus 1. So that's p of x equals n. P of x equals n minus 1. Well then, this first term is going to be x minus 2. This one's going to be minus 3. Minus 4. Austin, Chen, thanks for the follow. And then n minus 4 becomes n minus 5. And then lots of things cancel out here. And this one and this one? Wait, no, this one and this one. So what am I supposed to show? That it becomes 4 over 5? Okay, so let's see what we have. We have n minus 1 over n minus 4. And then we have a 0.8. And then 0.8 we can write as 4 over 5. So then we're done. Easy. Okay, hence, we need to show that x has 2 modes. Why do I have channel points? Why not? Someone told me to activate them. And then they also said that I don't have anything to use them on, so I need to look into that. Okay, so if you take p of n and then divided by p of n minus 1, this is related to the mode. So the mode of x is, you know, the one that's most common, which means that that has the highest probability. So if I equate this to 1, then that means that there's 2 values of x that have the same probability. So that means that there might be 2 modes. Something like that. Oh, you unlocked the emote. Yeah, I need more subscribers. Then I can get more emote slots. Oh, Snake Star, thanks for the subscription. I don't know. I figured this is a pretty good emote for a math help channel. Confusion is a pretty common expression, I feel. What do you mean, what is it? Yeah, it's confused frog. Anyway, so we're gonna take this, as I was saying. And we're gonna make it equal to 1. That's because you don't know pop culture on the internet. And that's a very famous green and blue blob. I forget its name. It's related to Pepe. It's not Pepe though. It's like a diminutive version of Pepe. I'm fairly sure when I was like googling this emote, it's not exactly Pepe. Pepe is older. Like this is Pepe. It's like a weird baby version of Pepe. Know your meme. See, this is Pepe, grown up and kind of sad looking. There better not be anything super inappropriate on this page. But like, Baby Pepe's something else. I forget his name, but he has a different name. Oh, right here. Apu. This is Baby Pepe. His name's Apu. Apu Apostaja. But anyway, so if we were to take the ratio of two probabilities and it's set it equal to 1, that implies that there's two with the same probability. No, it's not Kermit. Which means that there's two modes. So if I solve this, it's not Kermit. It doesn't look anything like Kermit. You're being... It's not racist, but speciesist. Just because they're both frogs doesn't mean that they're the same. And not all frogs look the same. Oh, man. Well, they're related. I mean, they're both frogs, but they're not... Pepe is not Kermit. And in no way do they look the same. They do not. It does not look like Kermit. Kermit's not sad. How can he be sad? Okay, so when n is 16, that also means that 15 is going to have the same exact probability. So, in other words, we have two modes. One at 15 and one at 16. Okay, so then that's done. And then last question, Oliver's mother goes to the market and buys N ice cream sticks. She takes the ice cream sticks home for Oliver to open. Determine the minimum value of N such that the probability that Oliver receives at least one free gift is greater than 0.5. Okay, so So determine this minimum value of n such that the probability that he receives at least one free gift is greater than 0.5. So it's something like this. I'm just gonna check. Oh. Man. Okay, so from what I gathered from the answer key, because I am not in the state of mind to do statistics. Okay, mom buys n ice cream sticks. Determine the minimum value of n such that the probability Oliver receives at least one free gift is greater than 0.5. I hate statistics. So y is how many different situations there are, right, that he wins one prize. So we want to find the minimum value such that this is 0.5. And apparently this is a binomial cumulative function. Right, okay. Because we need to look for okay. This is sticks. And then we want to find out when he has at least 4 sticks, the probability is 0.5. So this is easy because that's binomial. Because either a stick is coupon or not coupon. Okay. So then we just add all the different situations together, which is why it's a binomial Cdf. You know, take the probability of him getting four coupons. This is coupons. In 4 ice cream sticks, you add that to the probability of him getting 4 coupons in 5 ice cream sticks, and then we add those all up until it's 0.5. So then that's a binomial Cdf of n, and then the number of thingies we want is 0.2, and the upper bound, lower bound is 0 to 3. Okay, man, I'm just really out of it. So this is an upper bound, so we change this to a lower bound. Because cumulative functions start on a have an upper bound, not a lower bound calculation. So that's why our lower boundary is 0 and our upper boundary is 3. When do you use binomial PDF versus CDF? So when first off, you need to know what a binomial PDF is, probability function. So for example, let's say you're rolling dice, right? And then you want to count how many 2s you get, right? So you're rolling dice. And then you're counting how many 2s you have. And then if you know how many times you roll the dice, then this is a binomial PDF because you have a number of trials, which is how many times you roll the dice, and then you're counting a certain kind of result. So we're counting how many 2s there are. So you can say that in this one, your variable x, which is counting 2s, is binomially distributed. And let's say you roll it 6 times, right? So the way it's written is, okay, your counting of 2s is binomially distributed. You have 6 trials, and the probability of getting a 2 is 1 out of 6. So now we can ask the question, well, let's say you roll the dice 6 times, and we want to find out what's the probability of getting 3 2s in 6 dice rolls. So then this is a binomial PDF. And the P stands for probability. So what we do is we can put this into your graphing calculator. I have a TI-84. So you can go to second and then press vars. And then if you scroll down, here's binomial PDF. So how many trials? Well, we're rolling the dice 6 times. The probability of getting a 2, which is what we're trying to count for, is 1 out of 6. And then how many 2s are we interested in? The question I just made up said 3. So then the probability of getting 3 2s in 6 dice rolls is this probability right here, 0.0536. Yeah, it's coming back. Now this is very different than if I asked, what's the probability of at least, or at most 2, let's say. Or at most 3 2s. So sometimes you'll see the question and then it'll have it written like this. So this is different because the probability that you're calculating is an inequality. You're allowed to be 2, but also, you know, it's at most 3 2s. So then you can have less 2s. So then this is an inequality. X can be equal to 2 or less than 2. So there's 2 ways that you can calculate this. Well, the easiest way is, well, you just add up all the different scenarios. So the first one is, in the 6 dice rolls, you could have no 2s because that counts. You can then you add that with the next situation, which is you roll 6 times and then you only get 1 2. Then you add it to having 2 2s, and then finally adding 3 2s. So we have this. Now, when you talk about at least and at most, this is called cumulative. This is a binomial cumulative function because you're adding up different situations. So instead of physically, going through the GCD and putting in each one of these functions, they know it's a common question. So instead, what you do is you do Binomial Cdf. And what this does is this calculates from 0 all the way until the upper boundary. So, I should change this to 3. Sorry if that confused you. So Binomial Cdf will do this exact same process. It's just more efficient. So we can go to second distribute and go to Binomial Cdf, and it's the exact same format, right? 6 trials, we roll the dice 6 times. Probability of getting a 2 is 1 out of 6. And then x value, this is the upper boundary, the at most. So in this question, we want at most 3 2s, so the x value is 3. So 0.99. So that's what CDF is, and that's the difference between CDF and PDF. And then you just have to be careful because there's also questions that might say at least. So at least, let's say 4 2s. So that means that you can have 4 2s, 5 2s, or 6 2s when you roll the dice 6 times. So if you were to write this in the notation, this means that the minimum value is 4. You do the 1, the binomial CDF, yeah. So in this situation, we have an at least, and notice this is a lower boundary. This is the minimum amount. Binomial CDF calculates things using an upper boundary. So if you ever want to calculate in like an at least type question, you need to convert it. So luckily, we know that this is the complement to this. If I take 1, which is all probabilities, and I take away all the ones that are less than 4, then what I have left is the ones that are equal or greater than 4. And this is good because this is an upper boundary, so we can calculate CDF with it. But the only issue is you do need to change this into a proper inequality with an equal sign. And because x is counting stuff, right? It's whole numbers. Being less than 4 is the same as saying being equal to 3 or less. And we can calculate this. So to find out at least 4 2s, we put 1, subtract this thing. And this thing is, again, a binomial CDF. So then we can just calculate that for fun. So 1 minus second. Yeah. And then again, the only issue is make sure you're putting in the right x value. It should be 3 because we want less than 4. So then, again, that's less than or equal to 3. So there you go. The probability, if you roll it 6 times and you want 4 or more 2s, is pretty small. 0.008 something. So yeah, that's the difference between CDF and PDF. So back to this one. What was I doing? Okay, 4 coupons is 0.5. So then did all this stuff in the beginning of the year. And assuming you haven't reviewed it yet. Okay, so then I need to find out when this is 0.5 and then solve for the smallest n. I think as an HL student, you have the formula for the Binomial Cdf, which is unfortunate. Oh, apparently you don't. Why are they asking you this type of question then? By using GDC. You guys can't see it but because it's behind the chat, but it says you just use the GDC once you get to this point to solve for n. So I wonder if I can just do that. So can I even graph binom? Let's see. I never tried this. So let me change the window. I'm gonna see if I can graph the Binomial CDF. Which honestly, I have no idea if it will. I don't think it did. But apparently by GDC, then you can solve this thing, and then the smallest value that works is 19. Oh well. Most of this, I did the rest of this, but then yeah, this one is super weird. Okay, and then I think I'm done then. Okay, and then I checked my answers for most of these, so that seems all okay. And that was the last question. Not bad. These are difficult though, not gonna lie. But this one, this stupid goat problem, man, this one was wild. Okay, well with that being said, then I got time to kill. So time to ruin my thought process even more. And I can play some Baba. Unless you guys have math questions, of course. Well, even when I'm playing Baba, feel free to ask math questions, and then I can just stop. I was stuck. I think on stage 8. Okay, so this is the situation. The water is stop and open down here. And then right now I'm Baba, and then we have a flag behind my camera, and we have a key. So right now I am myself, well I'm Baba, and then I'm open. So then if I touch the water, which is shut, then I'm gonna die. Now I need to push the win, I think, out of the water. So if I push it in, if I try to get in here to push it, then it's stuck because now it's against the water and I can't push it anyway. So I can't go in this way. I need to somehow make a hole on this side or this side. So what I can do is I can change the key, right? And I can make the key be open. But the issue is there's no push anywhere on this, so I can't push objects because I need to say the word key is push. So I'm stuck. So what I'm thinking is that I can make, like for example, the key and Baba is me. So now I control both Baba and the key. So but you see, this is the issue. Now neither the key or the Baba is open, so I can't sacrifice one of them to make a hole. So I'm kind of stuck. And again, there's a flag here, but it doesn't really matter if I'm using the key or the flag. So any hints are appreciated. Otherwise, I don't know. I've been thinking about this puzzle on and off, and I'm still stuck. And then... But I guess I'll just keep trying stuff. Oh, and I guess I should change my title and things like that. So, Baba is you. Time. Like, really, there's not much I can do, right? Like, yeah, I can make the key is open. So now the key can open the water, but I can't even move the key. So I'm not sure what to do. I don't want to just be stuck on this puzzle for like 10 minutes, 15 minutes. I don't even know how long. So I definitely think, how do you play this game? It's a puzzle game. It's a little hard to explain now that I'm so deep into it, but basically, I need to win. So this is an adjective win. So I can make the sentence like flag, or key is win by connecting them together. So that means that if I touch the key, I win and I beat the stage. So I can break sentences and create sentences according to whatever I need to. So for example, it's not low-key coding, but you can see right now there's some conditions, right? The water is stopped. So what stop means is that I can't walk through it. And then the water is shut. So the water is shut means that if I have something that's open, for example, Baba, which is this thing, if I touch it, then it opens it up. But of course the thing disappears. Now, because I am Baba, then I die because I use it up. And I don't know, I don't think it's low-key coding. Settings, hold on. Oh weird, there's no window mode. So I don't know, I've been stuck on this one for a little bit. Cause like, what I can do is I can build the sentence key and Baba is you. So that means that now I control both the key and Baba. But I don't see what's the point in this. Is there a way to somehow like set up a sentence so that I can push it and then it changes to open? I have no idea. And I don't want to move on to the next stage until I figure out this one. But this is where I'm stuck. So I don't know what I'm trying to do right now. I'm playing around. So now key is open. So the key can open the water, but I can't push it. Like none of the rules say that I can push objects right now. So I don't know, I've been stuck on this one. Maybe I should just move on to this other one. But I feel like it just gets harder. Okay, so you see skulls defeat, so if I touch the skulls, I die. The pipes are stopped, so I can't go through the pipes. And then I have Baba is U, so I control Baba. And then robot is move. So when I move, the robot moves. And then if the robot kept moving, then he breaks my sentence, so now I'm no longer anything. So I have to figure something out. Yo, Bava is you, yeah. Except here it is. So I feel like first I have to intercept the robot, but how do I intercept the robot? Because he's just gonna kill me before then. But the title is called Stop the Thief, so... Oh, there you go. Okay, so now the robot's out. Did not break my sentence. But then, how does that help? I somehow need to get this win condition out of there. Oh, I know. So, let me just make the robot move again. And what he's gonna do is he's gonna bring the win to me. Wait, I can't push the win anymore. Shoot. Because this pipe is in the way. See, the plan was I thought I could push this all the way down here, and then eventually the robot will push it out of the skull, and then I can like play around with the win. But I can't even do that. So here's my robot, and he's just gonna keep walking back and forth. What happens if I do Baba as robot? Oh. Then... Okay, I have a plan. So I can make the robot go into the skull section. And then I can change the sentence so that it says robot is Baba. So that will change the robot into me. And then I can control it and then push it out of here. I think that's the plan. So let me restart. So first I need to make sure he doesn't kill me. And then I need to walk him into skull territory. And then I'm going to say robot is Baba. So this should change the robot into me. And now I can control the robot Baba and push the win out. And then I'm basically good. So because now I can just make the sentence Baba is win, and then I'm Baba, so I win. See, that one's so easy. But I can't figure out 8 for some reason. I don't know. Maybe it's just not my thought process. Oh well, why don't we move on to 11? Okay, prison. Alright, so what do we have? Wall is stop. The win is out here. Bob is me. Kiki's push. Well, Kiki's not push. It just says I can use Kiki and push. So here's Kiki. So let's see. So here it says Kiki is pushed, so now I can push Kiki around. Now the issue is the win is out here. So I need to somehow break this sentence, wall is stopped, because it's stopping me from going outside. It's also stopping other objects like Kiki from going outside. So like, I can't push them out of the wall. So how do I break this sentence? Well, wall is stop. But then the only other verb is word I have is this one. But then if I break that, then I die. So how does this one work then? I don't know. I wonder if this works. So the plan currently is to see if I can physically push someone through the wall, but I can't. See, I'm pressing right, but nothing's happening because the wall's stopping everything. And I don't know, I can't really break up this sentence, although apparently I'm supposed to be able to. I don't know. I guess when you have no idea, then you just gotta play around. So realistically, there's two options. I can make Kiki myself, but then this doesn't really do anything besides change who I control. I can make Baba pushable, but then I no longer am anyone, so that's not a thing. I can make a T shape. So now I can push Kiki around. But what does pushing Kiki around accomplish for me? I'd really like to use this is and I don't know, do something with it over here maybe. But I don't know. There's not a lot of options, which is weird. Boo Trick, thanks for the follow. Yeah, I don't know. This is another one that I'm stuck on. Like, I don't even know what pushing Kiki does to, like, accomplishes for me. What benefit is this? I have no idea. So maybe that's not what I'm supposed to do? But what else can I do besides make Kiki pushable? And of course swap control to Kiki, but then that does nothing really. Like, there's really nothing else I can do besides make... Besides make Kiki pushable. But then, like I said, I don't know what this does. Stupid Kiki. I don't know. I'm sure Kiki has a purpose. I just can't see what it is right now. Because I have to break up the sentence, which makes no sense. It's against the wall. So I can't move it. Because, like, again, I can only push stuff. I can't pull stuff away. I hate these ones. Because, like, there's so little options, and yet for some reason, it's not working. So that either means I'm making a huge assumption on what I have to do, or there's just something I'm not seeing. Because, okay, again, this is the setup. And there's two things that I think I can do right now. I can switch positions with Kiki, but that doesn't really do anything. Or I can make it so that I can make like Kiki is push. Then I can just push Kiki around, but apparently that doesn't do anything either, unless there's some weird pushing technique that I'm not seeing. Can I put Kiki into stuff? Like into words or into objects? Because the wall is stopped, then I can't push anything into a wall. And then this is another thing. I think this is, okay. I have a feeling I'm sort of getting somewhere. So while Kiki is push, wait, I don't even know if this is true. Hold on. While Kiki is pushed, that means that when I push it, so I just want to test something. So when Kiki's not pushed, then Kiki will go through objects that aren't labeled as stop. And then the moment that I make Kiki pushable, then Kiki will be able to push objects or be pushed by objects. So I think that's what I need to do. I need to use that somehow. I just don't know how. Because you see what I just did right here. Is I made Kiki pushable. And then when Kiki is pushable, you can't put Kiki into things. No, you can't push Kiki through the wall. I can push the text up and down. You have to be careful how you push the text. Because I can't push it up and down because then I break wall is you. How do I make wall is you? Because if I push this down, then I break the Baba is you sentence, so then I lose control. Push the wall text up and down. So if I push this up, then what? Okay, I think this might be it. So Right now, Kiki's pushable. So if I push this entire sentence, I will push Kiki into the wall. Maybe. Nope, never mind. The wall stops everything. But while Kiki's not pushed, then I can overlap Kiki with words. And then if I make Kiki pushable again, well, I don't even know what this accomplishes. Put Kiki above the wall, and then push the text up. So Kiki goes here, and then I make sure that Kiki's not pushable, and then I overlap here. Now what? Wall is push. How do I create the sentence wall is push? I can't move this out of the way. And then now I can make like Kiki pushable. Oh, wait a minute. I can make myself Kiki. So then what happens now? So now I'm Kiki. Oh, I broke it. I did it. Ah, okay. Okay, and then I just need to make Kiki as one. There you go. Jeez. Man. Oh, thanks, Bootrick. Okay, I knew you had to put Kiki into the text. I just didn't know what it meant for me to become the person in the text. Okay, 8 is killing me. I have no idea how to do 8. I wonder if it's the same concept. This game's called Baba Is You. Bootrick, have you played this game before? Okay, this one is a little different because nothing is pushable in this stage. It's either something is openable been a long time and you didn't complete it. It's called Baba Is You. I'm not 5 a.m. I'm sure you ended up farther than I did, though. So here's my initial plan, and I have no idea if this is right. No, it's not yellow, it's just faded. Last level's pain in the... I'm sure it is. So here's my thought process for this one, right? We need to push the win. It's a puzzle game. Here, I can probably better demonstrate puzzles with maybe a fresh one. Evaporating river. Okay, so there are nouns such as which are the words that don't have a background and are not white. So cog is a noun. This is a cog. There's Baba, which is this creature, right? And then you create sentences, and then when there are sentences, then whatever is the sentence is like a part of the game. So for example, Baba is me. So here's Baba, and Baba is me, so I control Baba right now. Now the skulls are right here, and then that's defeat. So that means that if I touch it, then I get defeated. The water right now is sink. So if I touch the water, then I sink. And then you can't see it, but behind my camera it says the wall is stop. So that means that the walls well, they stop you. You can't go through them. Now, here's the thing. As Baba, right? You can move things and break sentences. So now the waters no longer sink. So I can walk through the water and it doesn't do anything to me anymore. So the ultimate goal is to create some sort of sentence, something is win. And then when I touch that something, then I beat the stage. Okay, so let's see. Cog is push. So I can push this cog. And it melts stuff. So it melts things that are hot. So you can sort of see behind the chat window it says water's hot. So it'll melt. So I think the plan is, like, you have to make the condition flag is win. I think that's the only way you can make a win sentence. So I need to, my plan is to make like a stack of a couple items, and then I can push it along so that it'll push the flag into here. Now the issue is the cog is the only real option I have to push stuff. And right now, it's gonna melt when it touches the water because the water is hot. So let me see what I can do. So I gotta play around with these words that I have. Is water and the actual cog itself. So I can make the sentence cog is water, but that just turns this cog into water. So I don't think that helps. And then it looks like I'm pulling stuff, like if I do this, but I'm just pressing undo. You can't pull words and objects. I could also do something funny, like water is skull. So that means that now all the skulls, well, all the water skulls. Well, actually this might work, because then that means that the cog isn't gonna melt because only water's hot, but now I don't have water. So maybe this is what I'm supposed to do. So now I can push it across. So that's fine. But that leads to some issues, because now I can't break any of this, and I'm stuck on this side, and I can't do anything. Because if I push it, then I'm gonna die, because the skulls are defeat. But I feel like that's possible progress. I don't know. You guys can feel free to, I guess, give suggestions, because I don't know. It doesn't matter to me. Okay, this you guys can't see, but let me turn off my camera for just a quick second. That's not my camera. Okay, so you guys can see behind in the corner, bottom left corner, it says wall stop. So I'm just trying this out for fun. This makes all the water walls. Oh, I guess that doesn't do anything. So let me restart. Okay, well, first step I'm pretty sure is I can't move the flag because there's no sentence saying that I can push the flag. You need to say like flag is push. But this is the only flag in the stage, and it's not making a sentence with anything. So I can break this, so then now I no longer sync. And I don't know. My assumption is I need to move this cog over here. Join our Zoom call? I'm in the middle of streaming. Why don't you help me out with this stage, Jenny? I can't drag blocks. I can only push them. I don't know how much longer I'm going to be on for. I went through the rest of the math questions I wanted to, and then I wanted to kill some time because I was like under 2 hours of streaming at that point. You have a strange solution? Well, why don't you give it a shot? What do you want me to do? This is as much your guys' struggle as mine. Well, Butrick, you probably went through this stage already, but let's hear it. Move water sink to the right side, then sink a water tile using the word water. Alright, I can get rid of a water. Then move the cog to the top left, top skull, and then make cog a sink. Wait, hold on. You can't, well, the way that I did it is you can't make cog a sink anymore because I already used the sink to destroy the water. But then this accomplishes my original goal, doesn't it? Although I don't have enough objects to push it there. So... I need one more thing. Okay, so then what was your plan? Move water is sink to the right side and then sink a water tile using the word water. Okay, so you want me to use the word water. Now, how do I push the word water into here while maintaining its sink qualities? Because each time I push it, then it's not gonna sink. I mean, I could push this, but then all three of them explode. And I don't think I want that. move the phrase to the right size. The entire phrase? Oh yeah, okay, that makes sense. Oops. Can water be horizontally pushed? Well, I mean, I guess if I do it this way, then I can kill the water. And then now I can make the sentence cog is sink. So then if I make the sentence cog is sink after I sink the water, then you can move the cog to the top left skull and make cog is sink. You need to sink the word water to do it a weird way. Actually, I can't even get this is over here if I were to push it this way to sink the water. You can. Yeah, that's true. I mean, what does this accomplish? Flag is sink? Oh, and then I guess, but I can't even put, oops, wrong skull. Oh yeah, whoops. Oh, I got you. Jeez. Yeah, okay, I got it. Oh yeah, it's so easy. Oops. Yeesh. Man. You know, I wonder how they come up with these stages. Because it seems like making the puzzle is almost as hard as finding out how to solve them. Okay, let's see. Pipe is stop. Baba's me. Flag is flag, which means that I can't change the flag into anything else. The bog, which I'm assuming is this green stuff, is defeat. And then let's see. Cog is stop. I have and move, and then push. I can push the robot. And then over here, I have flags, rocks, and the word win. Okay, just want to confirm that that's the bug. So what can I do? I can push the robot. And then he's not gonna die. And then now he can move. But the issue is, he only goes in one direction. So is there a way for me to like make him go up and then back? To push out the wind? Who knows? So each time he hits a stop, then he'll just bounce the other way. So what? Do I need to move the cog and set up like a... Move the cog first to set up a course for the robot? But he just bounces back and forth. He doesn't change direction, right? Like if he just bounces on the pipe, then he'll go left and right. He doesn't change going to up and down. Let's see. Okay, let me get him over to this side. And then let me see if I can set this up. So I want him waiting here. The T from Winter Call? Well, I guess you'll have to wait until I can spell it. Okay, now, what's the plan? What happens if I move the cog and like leave it here? But then this, and then change it to stop, and then the robot will just bounce back and forth. Let's see. So many options. Because let's see. I could make like a sentence, rock is win. But the issue is there's no rocks in this stage. And you might be thinking, oh, I can use like the other is to make flag is rock, and that turns the rock into the flag into a rock. But then they thought about that, and that's why they said flag is flag. So you can't change flag. I guess you can make the word flag and rock is win. So let's see if that's possible. Well, first I want to check something out. Okay, I just want to see how deep this is. I think this is 2 spaces, right? So 1, 2. Okay, well, we'll just play around with this and see what happens. Yeah, you should start your history. Okay, so now the rock is win. And then is there a way to get the word is here? Not really. If somehow I made the sentence rock is moved, then depending on the orientation, it will move in that direction. So you see, if I push the robot to the left and to the right, now he faces to the left and to the right. So if I move him, then he'll move towards the left and to the right. If I push him down or up, now he's facing this direction. So now if I make him move, he goes in this way. Up and down instead. Cog is move. Can the robot push and... See, it would be nice if I could get the word and here somehow. So let me load it up, I guess. And then I guess I can just try to time this so that when the robot pushes it here, I will be ready to move into the flag. Okay, so let's set this up. So when I push this, right? I push this up. Then I have a limited amount of spaces until the and will hit here. So the moment the robot pushes the word to make and, I need to make sure that at that time that I move, Baba will also move into the flag. So then I need to move 1, 2, 3, 4, 5, 6, 7, 8. Oops, try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now the robot is going 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think, let me just double count. Measure twice and then cut once. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm gonna try this out. We'll see if it works. One. Oops. Make sure he's facing the right way. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Nice. Alright, I think I'm gonna call it there. I did want to solve that problem, or that stage, and you know, it's almost been 3 hours. But anyways, thank you new people for following me, and yeah, I guess I'll stream more math help on Thursday, and I don't know, Baba comes every once in a while whenever I have free time and I finish like a test early or something. But anyways, well, have a good night guys, and talk to you later next Thursday.